Okay, so as you're kind of finishing that up here, I'm going to start talking through this. Have you guys done composites of functions before? Does this seem somewhat familiar or not familiar? Eli says yes. Everybody else, yes-ish. Okay. I can't remember, or I couldn't remember if this was something that like got mixed in the Algebra 2 stuff or not. We talk about composites in geometry some. Like we used that little dot symbol for geometry when we did like rotations and reflections and stuff like that. Like we do a reflection over one line, then a reflection over another line, and then it ended up being like, you know, a translation or something like that. But we did use that symbol a little bit in geometry. So this is basically just combining it with functions then. So taking like multiple individual functions and then combining them all into one function, where you do one and then take that answer and put it into another one. How that's read out loud, so the G and then that little composite circle in the F is composite of G with F. I never remember to do that. I always call it like G of F of X or whatever, but that's the official way of actually reading it. And then just a reminder with these, when we do them, you always work them in the reverse order. So just like order of operations, whatever's in the innermost parentheses, we do that first, and then you take that value and keep working your way out from there. So here we'd start with whatever the F of X was, figure that out, and then take that answer, put it in for the G of X. Same thing here, so these mean the same things, just written with that composite symbol instead, but you're going to start with the F, get that answer, and then put that into the G. And then they give the actual like clear-cut definition of that. So suppose F and G are functions, composite of F with G written, G, and then that little composite symbol F is the function defined by, and then they use the same kind of symboling we've got there. And then it says the domain, or like our X values of that, of G, composite symbol, and then the F, is the set of values X in the domain for F, for which F of X is the domain of G. Just because you get a domain of one of the individual things, so like if you've got the domain of F of X and the domain of G of X, that doesn't make that domain the domain of like the composite of those, okay? So the composite of it might be the same as those domains, but it could also be something completely different. So you almost have to like figure out the composite first, then figure out what the domain and range are. And then it's also not commutative, so if you go like the G and then the F and then the F and then the G, have you guys heard of these called like fog and goff? So like I always call this the fog goff stuff because that kind of looks like fog and then that kind of looks like goff. So if you ever hear me talking about fog and goff, it's just this composite stuff that's just easier to say than the composite of blah blah blah. But those are not commutative because just because you go one way, if you flip it around, you might not get the same answer the other way. And then there's going to be a couple questions on the assignment that have to do with this family tree thing. So if you've got your book, there's this family tree that's on page 193. I'm going to kind of talk through what the functions have to do with that family tree. So as long as you got that picture open, what they might do is they might say in the family tree, like M of X is the mother of whatever your X value is. F of X is the X value of, or the father of whatever your X value is. You don't have to write this, I'm just going to talk through it. And then, so if it's a situation like this, where it says like M of John Quincy Adams, what would that mean? The mother of John Quincy Adams. And then what you would do is you would just look at that family tree, and if you follow up there, who is the mother of John Quincy Adams? Abigail Smith, right? So if they ask a question like this, okay, that means mother of whoever that is, John Quincy Adams, you would just look at that family tree and see that that's Abigail Smith. And again, you don't have to write this stuff, we're just talking through it. And then what they're going to do is it's like a composite here, so they're just going to take that value, put it in for that, so then it would be the father of Abigail Smith. And based on that picture there, or that family tree, who's the father of Abigail Smith? William Smith. And then the Rev just stands for Reverend. So Reverend Will Smith. So then here, the reason that they do that, like kind of ask for the mother of John Quincy Adams, get that, and then put it in there, that would be the same as writing it out just like this, where you find the mother of John Quincy Adams first, then you find the father of whoever the mother was. So that would kick out that same Reverend Will Smith. So there might be situations where they use like, the family type tree thing there, but it's asking the same concepts, just instead of an equation, they're just asking for words. What do we call this if it's your mother's father? Anybody know what that's called? Your mother's father? What would that be to you? Yes. Yes, maternal. So maternal stands for it's on your mother's side, so this would be your maternal, and again, you don't have to write that, maternal grandpa, because it'd be the grandpa on your mom's side. But if they're ever, because I know there's some questions in the on the assignment about that, so that's kind of what they're talking about. Okay? All right, let's get, yeah, I wrote it as Will Smith. Thought that was funnier. Okay, so let's go to the example sheets then. Hopefully it's not too bad if you guys have already had some of this stuff before. Okay, so here we got our two functions. We got f of x is equal to x squared, and g of x is equal to 1 over 3x plus 1. And then for part A, they want us to do f of g of 4. Okay, which one do we start with there? Do we start with the f or the g? The g, because we're always working inside out. So what I would do there for A, I'm going to do it up here because we probably need some room to solve these out. For this one, I would take that 4 value and put it into that g. So basically, you're figuring out your g of 4 first. Which would be 1 over, and then whatever that value is, we're just putting that into the x spot. So 3 times 4 plus 1. So 1 still on top. 3 plus 4. 3 times 4. 12 plus 1. 13. Okay, so that's 1/13. And then what do we do with that value? Yeah, plug it back into the f of x one, right? So then we'd go f of that 1/13 is equal to, so that one's basically going in there. So then it would be 1/13 squared. So I just do 1 squared is 1, 13 squared is 169. So 169 would be our answer there for part A. Okay, and then B, same thing except what's different here? Yeah, we're going to plug into the f first, right? So here if we plug into the f first, it'd be like f of 4 is equal to, and then we're plugging into that f function, so 4 squared. What is 4 squared? 16. And then you're putting the 16 into the g1. So the g1 would be 1 over 3, and then we're putting that 16 in there for the x spot, plus 1. 3 times 16? 48 plus 1? 49, so 1/49 would be that one. And then obviously you can see there, just because the letters were the same, when we switch the order around, it's not commutative. They don't kick out the same answer. For part C here, do we even actually have to solve anything on this one, or have we already solved it? We've already solved it, right? Which is C going to be the exact same as? The answer for A, right? Because aren't those just the same exact thing, just written in different notation? Yeah, so we don't even have to write anything out there, because if you figured out what A was, C is the same thing. They just put that little symbol in there instead, but the order of it's the same. So C would just automatically be the 169. You wouldn't have to do the solving out because it's the same as what we started with. If you wanted to plug in, you could, but I think we got that. All right, cool there? Okay, so next one here. Now what they're going to do is they're not going to give us numbers to plug in. They're just going to give us the same setup, so like f and then the composite g of that x there, but they're going to ask us to do it with the full formulas instead of just the numbers. Okay, so for the first one here, I'm going to write it with the parentheses, so it'd be like f of g of x is equal to. Okay, and they're just using the same exact f of x and g of x from that first example there. So we want to take our g of x value there, which is the fraction one, and we want to put that into the f of x one. Okay, so our f of x one is just x squared, so that's going to be kind of our outside one. And then our inside one is the g of x one, where it's the 1 over the 3x plus 1. Have you guys done anything like these ones where you do this too? I'm wondering why this section's in here if you guys have already done all this stuff. Whatever, we'll make it an easy section. Okay, so then anyways, with one like this, you'd want to simplify it out at least a little bit. So I would do, if we do 1 squared, just 1, right? And then the bottom, up to you. You can either just leave it as 3x plus 1 squared, or you can keep taking it further and do like the whole FOIL thing out and find all your bottom. I'd be cool with that if you just leave it as that, because we just basically have to figure out that both of those things aren't the same. So as long as you can come up with something like that, you should be cool. And then for B, we're just doing the same thing, except for now we're doing g and then the f. So now we're taking the squared one and putting it into the other one. So this one would be g of f of x And like I said, the squared one this time is going into the fraction one. So you're going to have 1 over 3, and then instead of the x, that's where we're putting the x squared at. You can put that in parentheses if you want. You don't necessarily need it, I guess, in this case. And then you put your plus 1. And then, like I said, you could have it with or without the parentheses. If there was more to that x squared, you would definitely... Oops, I put the parentheses there again. If there was more stuff there than just x squared, you would definitely want parentheses. But in this case, since it's just the x squared, you don't really need them there. But if, say, it was like x squared plus 1 or something, you would want them there because you'd want to distribute the 3 to everything. Okay, and then what they want us to do for part C is just verify that those two don't equal each other by graphing. So clearly we can see that they're kind of similar to each other, but they're not exactly the same because there the squared's on the outside and there it's not. And even if we did the foiling out on that, it still wouldn't be the same as that. So when they want us to graph it, I would just take what we get for these final answers here and plug those into our graph. So first one, 1 divided by 3x plus 1, and then make sure we got the power of 2 in there. Okay, that's my graph for the first one. I think I'm going to zoom that in. Okay, so I zoomed in. Oops, can you see it? I zoomed in a little bit there on that one. Just zoomed in once. So that's our first one. So I would just do a little sketch of that. So and that was the first one, so that was f of g of x. And then I just type in the second one, which is 1 divided by 3x power of 2 plus 1. Graph that one. And you should get something that looks different. So that one's kind of like peaks up in the middle there and then comes back down. So that one I'll do in a different color. So that one kind of like comes in here a little bit and then like kind of peaks up there and hits that line and then kind of comes back down there like that. That wasn't a great picture, but that's the g of f of x. So that would kind of verify that they're not the same graph, because if you look at them, they're not the same. You could also say that like they only have certain points in common, so they only cross there and there, and you could list those specific points, but I'd be cool with just the graph. All right, next one. Okay, use the functions f and g in the additional example to find the domain of f of g. Okay, so our original ones from the previous page, f of x was equal to x squared, g of x was equal to 1 over 3x plus 1. Okay, and we're supposed to find the domain of the fog one there. We already found that equation on the previous page, so instead of plugging it in and doing it again, I'm just going to take the one from the previous page. For the fog one, which was the top one we did. So 1 over parentheses for that one, 3x plus 1 squared. And then we need to find the domain. Is domain our x's or our y's? The x's. So when we go to graph this here, you can kind of see it a little bit, so I'll get rid of the second one. So it's the graph that looked more like the volcano there. So obviously we're going to have that asymptote in there, and if it's domain, do we care about the x value or the y value for this? The x value, right? So the y value going across this way is irrelevant to us. We don't care about that. So we just care about where it's not equal to x right there, kind of where our asymptote is. So the x one's the easy one, where we just take the bottom and set it equal to 0. So what I would do is I would just take that bottom value there, the 3x plus 1, in parentheses to the power of 2, set that equal to 0, and then I just solve that out for x, because that would be where our bottom is equal to 0, which we can't have for x. So then to get rid of squaring, square root both sides. So we have 3x plus 1 is equal to, square root of 0 conveniently is just 0, so do we have to worry about the plus or minus with that? Not, because there's not a positive 0 and a negative 0, so we don't have to worry about plus or minus, which just means we're going to have one answer. And then we just keep solving there, so minus 1 on each side. 3x is equal to 0 minus 1 is negative 1. And then divide by 3. So x would just be equal to negative 1/3. And then what does that tell us for domain purposes? It's the asymptote, which means what for domain? Can it equal that? No, it cannot. So for domain, then, I would just say all real numbers. You could either say, like, except negative 1/3, or you could say, like, all real numbers not equal to 1/3, or however you want to say that would be fine. So all real numbers except negative 1/3 would work for that. And then you could always check that on your calculator if you wanted to. So if you go to second trace and then value, that'll ask you for an x value. If you type in negative 1/3, it'll give you nothing there, which is accurate because it means it's not crossing there. Okay? All right, just a way to double check. All right, last one here. Okay, so we've got a scale change one there. That should probably be a capital S. So let the scale change be x just stays the same, and then y is divided by 3. And then they also do a translation there. X is minus 1, and y is minus 2. And then the first thing they want us to do is describe S and T in words. Okay, so S for our scale change. What's going on with that there? What's happening with that scale change? Yeah, so divided by 3, yep. And then which is that? Is that the horizontal that's changing or the vertical? The vertical one. So I would just say S is a vertical scale change of 1/3. Okay. And then the second one for the T, what's that mean? Translation. And then what do we think about, like, what's the x mean? Left, yep, and it would be 1 there, and it's left because it's negative, so translate, or T is translated left 1 unit, and, okay, and then what about the y? Down, yep, so since it's negative 2, that would mean down, and down 2 units. Okay, good deal. All right, and then it says write a simplified formula for the composite of T composite S, X, Y, and describe it in words. Okay, so that would just be combining those movements together into one. So if it's T composite S of that ordered pair X, Y, we're going to plug that stuff in and figure out what our new ordered pair would be here. Okay, so we're starting with the S, or our scale change movement, which was the nothing for the X, and then the Y divided by 3. So we put that in to this one here. So basically taking those values there, putting them into that there. So the X is just going to stay the same, right? So the X spot just goes into there. So just X minus 1. And then we're going to take this scale change of the Y divided by 3 and put that in for the Y of this here. So that's going to change, instead of Y, that's going to change to Y divided by 3 minus 2. So just taking that scale change movement, putting it into that translation. So now when we're doing this out here, when we say it in words, then which one are we doing first, scale change or translation? The scale change. So I would just say first is a scale change of 1/3, or maybe we should put a vertical scale change of 1/3. And then followed by, and then that's the translation part. So translation, left 1 and down 2. So just kind of repeating the same stuff, just in the order they ask us for. Okay, and then part C of that, same thing, except for now we're switching around the scale change and the translation. So this time the translation's first, so it'd be a scale change composite with the translation of that same ordered pair X, Y. And then we'll plug in there. So this time we're taking our translation information and putting that into the scale change information. So you're taking these values and putting them into those spots. So the first one's actually going to stay the same, because if we take this chunk of x minus 1 and put it in the x spot, isn't it just still x minus 1? Yeah, so that one still stays x minus 1. But the second one's going to look a little different. So we're taking this chunk here of y minus 2 and putting it into the y spot there. So it's going to be that whole chunk divided by 3, because it's replacing the y. So it would be that chunk, y minus 2, divided by 3. So just a little slightly different than the previous one. And then for your like word or describing words, you just do the translation part first. So you would just say first is a translation, left 1 and down 2, followed by vertical scale change of 1/3. So a lot of repeating the same wordage there, but the order of that does matter, and it changes a little bit when you plug back in. Okay? Alright, hopefully this won't be too bad. I didn't know you guys already knew this stuff, so hopefully it should be pretty simple. Maybe a couple new things, but hopefully a lot of review. So you got that book page 197, 1 to 20 for tomorrow, and then tomorrow we'll go on to inverses.